Hi children, hope all are fine. Welcome back to today's class. Today we are going to watch few videos related to the previously taught topics: the relation between electricity and magnetic field and magnetic field lines, magnetic field around a straight conductor and a looped conductor, right hand thumb rule, solenoid and electromagnet. Let's watch.
A compass needle, when placed near a magnet, gets deflected. This is because the magnet produces a magnetic field around it. Are magnets the only source of magnetic fields? The answer is no. A current carrying wire or a loop can also produce a magnetic field around it. This was a coincidental discovery made by a scientist named Hans Ørsted. Let us study the various experiments which Ørsted performed to demonstrate that a current carrying wire is indeed a source of a magnetic field.
We all know that magnets are made up of two poles, the North Pole and the South Pole. You are familiar with the attraction and repulsion between the magnetic poles. Like poles of magnets repel each other. Opposite poles, or unlike poles, of magnets attract each other. We know that a compass needle is made up of a tiny bar magnet. It gets deflected in the magnetic field because of attraction between unlike poles and repulsion between like poles. Now, let us do a small experiment to detect the magnetic field. Place a sheet of white paper on the bar magnet. Sprinkle some iron filings on the paper, then tap the paper gently. What do you observe? The iron filings arrange themselves in a pattern. This pattern indicates that the magnet exerts an influence around itself, which is the magnetic field. The iron filings get attracted to this field and arrange themselves along the field lines, which are called the magnetic field lines. An electric current passing through a conductor also produces a magnetic field. We can observe this magnetic effect of electric current with the help of a simple experiment. When the current is switched off, the nail becomes magnetic. It attracts the stapler pins, which are made up of iron. When the current is switched off, the nail loses its magnetic properties and the stapler pins fall down. Magnetic effect of electric current is all around us. In fact, you can encounter the magnetic effects created by a flowing electric current anywhere you have an electric motor in use. Just as a flowing current creates a magnetic field, a moving magnet can also create electric current. Electric generators work on this principle. Do you know that a straight current-carrying conductor creates a circular pattern of magnetic field lines around it? The direction of the magnetic field will reverse if you reverse the current flowing through it. Similarly, the magnetic field will increase if you add more batteries to increase the current. Now, what if we bend the conductor to make a circular loop? Will the pattern of magnetic field lines remain the same, or will it be different? Let's check. Switch on the circuit to observe. When the current starts flowing through the loop, each point in the loop creates a circular magnetic field around it. This magnetic field decreases as we move away from the conductor. It appears as a straight line at the center of the loop. Click on the battery to reverse the current and observe the change in pattern of the magnetic field lines. Now, increase the current by adding one more battery. Click on the battery placed near the circuit. Did you notice that the deflection of the compass needle increased and the number of stapler pins that got attracted towards the loop also increased? This shows that the increase in current results in increased magnetic field. Now click on the loop to increase the number of turns. Did you notice that the deflection of the compass needle increased and the number of stapler pins that got attracted towards the loop also increased? This indicates that the increase in the number of turns increases the magnetic field. So what did you observe? A straight conductor will have magnetic field in a circular fashion around itself. The direction of the magnetic field will reverse if you reverse the current. The magnetic field will increase if the current increases. Similarly, each point in a looped conductor will have circular magnetic field around itself. The direction of the magnetic field will reverse if you reverse the current. The magnetic field will increase if the current increases. If the number of loops of the conductor is increased, the magnetic field will increase. To check the direction of magnetic field produced by the current carrying conductor, we can use right-hand thumb rule or Maxwell's corkscrew rule. If you hold the current carrying conductor in your right hand in such a way that the thumb points towards the direction of current, then the fingers will wrap around the conductor in the direction of the magnetic field lines.